All right, after everything we have learned about gravity, what do you know about microgravity?
Microgravity is itty bitty.
Microgravity, I guess it would be like little gravity. Maybe just a little bit of keeping you down.
Microgravity is a very small gravity.
Wherever you are in the universe, there's always a little bit of gravity, and that's microgravity.
Microgravity is super, super small. Like when you order the extra large fry at a restaurant, it's the exact opposite of that. It's like the really tiny, tiny fry, but it's gravity. So it's like a super tiny fry of gravity. It's really small. It's like super small, super small.
Microgravity is gravity in space. There's little of it, that's why it's called microgravity.
You just float all around.
Micro means little, and since we know what gravity means, if you put them together, it means little gravity.
I forgot this guy's name. His last name's Armstrong.
Microgravity is what astronauts experience in space.
Very good. I still think, just to clarify, we should go ask a scientist.
When you have astronauts in orbit, they are going through an environment in what we call microgravity. Now, microgravity doesn't mean no gravity. Microgravity means a very small amount of gravity. And one of the reasons for this is that when you are on the Earth's surface, you have 1g, or 1 gravity. But the further away you get from the Earth, the pull of the Earth's gravitational field gets less and less and less. So when you get into orbit, 100 miles, 200 miles above the surface of the Earth, the gravitational field of the Earth is small, but it's not nothing. So that's why we call it microgravity as opposed to zero gravity.
Microgravity is a term used by scientists to mean very little gravity. The effects of gravity aboard an orbiting spacecraft like the Space Shuttle or at the International Space Station are reduced significantly compared to what we experience here on Earth, which is why astronauts are able to float around so easily. The micro in microgravity is a common prefix used in science to mean 1 millionth. The symbol for the word micro, or 10 raised to the power of -6, is this. And the symbol for microgravity is this. The reason scientists prefer to use the term microgravity instead of zero-g is that no matter where an object is in the universe, there will always be a little bit of gravity acting upon it. Besides astronauts, people experience microgravity every day by riding roller coasters or jumping off diving boards. It is the freefall period of these activities when the microgravity occurs, and of course only lasts for a short period of time. Here's a coin. When I toss it up in the air, I have just subjected that coin to microgravity. From the time it leaves my hand until I catch it, it is experiencing microgravity. The time in microgravity might be 1 to 2 seconds depending on how high I toss the coin. For extended periods of microgravity, say longer than a second or two, certain special conditions have to be present. Drop towers typically offer about 5 seconds of microgravity, and parabolic flight, like the one I'm about to go on, offers about 25 seconds of microgravity. Let me give you an example of what would happen in a drop tower that you most likely have experienced: an elevator. Suppose I was standing on a scale in an elevator that's at the top of a skyscraper. I would see on the scale that my weight is 132 pounds. Now suppose somebody cuts the elevator cable. What will I see on the scale in my free fall down the elevator shaft? Ah! Now before you answer that, take a moment to look at what's happening. Ah! The elevator floor is falling, the scale is falling, I'm falling, everything is falling. Ah! So to say it as simply as I can, anytime you were able to move freely in response to gravity, meaning that there is nothing to restrain you from accelerating or decelerating, you are weightless or experiencing microgravity. For longer durations of microgravity, we must devise more sophisticated freefall methods. Remember me talking about Isaac Newton? He helped us understand that the further an object is away from the Earth, the less it will be attractive.